Okay, try now. Go ahead.
Okay, thank you. Apologies. So in the area as well, high-tech engineering representation. And recently we've been in the news for other purposes as well. You may remember last year debates about during sort of periods of unrest during lockdowns, about the debate about racial equality, and also the heritage of a city that relates to part of its older benefactors being part of slave trade and so on. The debate that this brought into Bristol was one of the spots in the centre in this discussion in the UK. So certainly you may have seen us in the news in this respect. We're also part of what is called the UK Collaboratorium for Research and Infrastructure in Cities, and this is where the support, if you like, for developing a concept like the observatory, the urban observatory, came from. And that represents about a dozen of English universities, at least in its inception. A bit more, I think, these days, that were funded to develop national research laboratories. I think the total funding is in the region of 140 million pounds sterling. National laboratories for infrastructure research and city research that were meant to be facilities within four walls, and indeed there are about a dozen, if not a bit more of them, all over the country. We have built one in Bristol. My colleagues in the civils have built a lab on structure, foundation, soil interaction facility called SOSFI. There are other labs that look into buried infrastructure, for example, railway systems, people-space interaction. They're all over the country, hosted by collaborating universities. But along with that sort of mainstream of support, if you like, that funded national facilities, there were also the idea to try and facilitate work at large. We cannot really facilitate work, research in the cities if you're not connected somehow in the openness and the wilderness of the city itself. The national facilities are great, but they're within four walls and they operate as university institutions, as university facilities. And so the research that will take place will have that nature of academic research. There was so the second strand of UCC funding, about £8 million, that funded 6 universities to develop that network, or that concept of urban observatory, defined as an entity that would be able to gather robust urban data that would help the hosting city and the hosting university to understand and develop better insights about city problems on mobility, energy, climate change, and link better the problem source and the stakeholders that care about that with the expertise in these universities. For us, it would be, for example, an opportunity to develop and validate theories based on those observations, to try and innovate in collaboration safely with city stakeholders, and even pass data on to the cities who are making decisions for planning and other purposes to be able to have better informed decisions on key aspects. And of course, in an academic fashion, share that learning and develop on that meaningful collaborations. This was in the context of that funding and research that will be achieved through development, design, and deployment of urban-wide sense networks. I'll show you some examples from our own observatory. There are 6 around the country. All have their own unique character. And developing data sets and curating those data sets, allowing access to people that need to have access to those data sets in order to develop their ideas. And so UCC essentially has delivered a network of observatories. And all of us have worked in developing collaboration facilities and ways of getting in sync, if you like, with the pulse of the city that I mentioned in their own unique ways. Every place, it has to be place-based in different cities. That allows us to do work like the little sort of activities and projects that I'll describe briefly a bit later on around the city of Bristol. And this is the map of the National Observatory network. We're down here in Bristol. The first original observatories, that strand of UCC is led by University of Newcastle, which was the original urban observatory. The first three that were funded was Newcastle, Bristol, and Sheffield. And you see there was a bit of diversity in terms of naming and so on. Then the next branch of observatories, there's a bit more consistency of everybody's name. Urban Observatory. I'll show you why we called us an infrastructure collaboratory. A little bit different of the first three observatories, as well as Sheffield, who was again a bit different than the other two, and the original one that was Newcastle. So we are the infrastructure collaborator, Bristol's UCREC Urban Observatory, a portfolio of related activity in urban sensing on a number of projects around the city. We're not a formal research group in that sense. More of a collection of interests, coordinated and hopefully well interfaced across not only engineering, but we work with people in geography, we work with people in policy studies, we work with people in applied psychology, and of course within engineering, all departments and across our schools, and also work with a lot of stakeholders in the city. 5 key themes have emerged over the 5 years or so that we're working under that kind of ethos. We care about infrastructure asset monitoring, things like the bricks monitoring that I'll get into a bit more detail later on, the crystal suspension bricks, energy systems and understanding energy consumption and sustainability issues around that. Mobility and people space interaction, particularly active mobility, people moving with bikes or walking around the city. Water quality, particularly looking at the floating harbour in Bristol and working with the council there. And also a lot of citizen science-driven initiatives where we enable citizen groups that may be interested in understanding something in their vicinity a bit better using sensing technology. We facilitate their access to this kind of technology and skills. And we have a number of small citizen groups that come and worry about air quality or impacts of spatial layouts in the neighborhoods, maybe pedestrianization or one-way chain systems and so on. And they're asking how can we understand the impact that this change would truly have to us, and we support a number of groups who come in with queries like these. A lot of us are based in Tower View, which is impressively the second oldest structure in Bristol. This Watts Tower is not as impressive in the sense if you're based there because it's a listed building, and there's a lot of issues with that. If anyone sort of put a hammer a nail on the wall without filling a lot of paper, but also it's situated, it's a small building situated now, these days, meaning in the 15th century might have been a great watch tower watching over Clifton Hill, the rest of Bristol, but now we're situated within the main engineering building and chemistry, so a lot of the view is actually white coats going by in labs. So there's not a lot to view from Tower View. We also have a little facility in the city's business technology incubator, the Engine Set, which is our UCREC pod here. And effectively, it's a meeting and collaboration room. Unfortunately, for the last couple of years, not been used as much as we would like, but we thought that having a presence at the city's business incubation hub, as its Engine Set, will give us also another interface with a lot of key activity related to technology in the city for us to plug into. We're supported by a number of projects that provide resource for people to come in and work with their equipment. I mentioned that UCREC was all capital equipment. So you can buy the technology, but you have to have the people to work it. So a lot of the projects, a lot of grant architecting would take place to align researchers and research interests with the existing infrastructure and allow them to do work. And we've got a number of researchers that are supported by grant sponsors through a number of programs, EPSRCs and UK research funding, ICASES, for example, or National Productivity Investment Fund, or Centre for Doctorate Training, centres for doctorate training that we're part of. And they may have, for example, research students that are interested in working in those projects. So that's sort of the setup and very high level nature of facilities and the different test beds that we have. And I mentioned that we've got interest in monitoring infrastructure in the built environment. I'll give you some ideas and where we take inspiration for working on problems, starting with the built environment. And interestingly, a few years ago, before the pandemic, there was a student union paper looking at student housing in Bristol. I think it was a national sort of interest at the time. It wasn't just a study in Bristol, but the Bristol sort of data was also published in a publication in internal or an external publication of the Students' Union. And a lot of students were reporting that were experiencing conditions that were not ideal, like experiencing mold, for example, and damp in the houses. One in five sort of reporting that 1 in 5 landlords weren't particularly active in dealing with the problem. I have mentioned under the banner of Zoom, I think we've got a note that it's about 150 responses, so it's quite a good number of students responding to this. And of course, a good number of students wouldn't recommend the city, and that's not good. Want the city to be welcoming to students, and we thought about looking at this in a bit more detail, so that we understand, where people live and how sort of the potential for this kind of problem develops over the course of their time there. Either sort of, development of damp on ceilings or on walls, and what causes the problem. Of course, there's a lot of work in the literature that looks both into the development of this as a problem in accommodation, and the impact that actually affects fairly negative, particularly students who are not necessarily going to stay for long periods or have not got the power, if you like, to negotiate with landlords to bring them in and do necessary modifications where more structural work might be required. And so there's a lot of things in the literature. If not anything else, also landlords, sorry, this is not very clear here on the projection, but it's part of the relevant law that says that that should be free of damp. That somebody who provides accommodation, a rental accommodation, ought to take a number of actions to ensure that this happens, and part of free of damp is one of the responsibilities. And so it was an interesting problem to look at, and of course there are some types of damp that are very difficult to do anything about because the structure, and you need to bring builders in, like rising damp or penetrating damp. But there are a lot of issues that are caused by condensation alone, which is sort of the amount of potentially moisture that exists in the air and could be liquidified, sticking on walls and so on, and cause the problems or exacerbate it. And there's a lot of things you could do about that if you know about it. And because you can open the windows, for example, or use a heating element and so on. This was interesting at the time. We realized that, and we were discussing that with people at the university, because we also had a Lighthouse European project called Replicate. And one of the actions was about getting students, getting citizens, not just students, to appreciate work with sensors and what they can sense in their own environment. And these weren't students, they were citizens of large, if you like, coming in from communities. And one of the themes that were well picked was that people were concerned about the conditions of their accommodation, particularly the rented one, and what they could do. They built an evidence base that showed whether there's a problem or not of any nature, and use that to negotiate with landlords to take action. And one of the themes that emerged in resonating what students were experiencing was exactly the damp that you can build in house. Part of the objectives of that initiative was to help people contribute to the design of sensors for the problems they were articulating. And so this came through engagement through Bristol Partnership, that we had a Bristol pilot under that project that engaged with citizens, with a number of other stakeholders in the city and partners on the project to develop an elementary sensing solution for sensing temperature and humidity. And it's a very basic prototype that was developed with the help of citizens, a Raspberry Pi with sensing elements in an enclosure that was built on site in a collaborator's workshop. And it was designed in a way that would facilitate the right sort of measurements, so it wouldn't inhibit temperature or humidity measurements presented by openings and so on and the right. And quite imaginatively, people suggested it would need to look like a frog because it was it's an animal that likes sort of wet conditions. So that's sort of the sensing elements, if you like, that we used for that. They were used as part of Replicate, but we used it in the study of humidity. And there's a number of actuators that are not sophisticated in the sense that they don't have to be automated, but people's dehumidifiers, heating elements, and simple ventilation. Opening the window is part of the actuation picture, if you like, if you want to build an image of, what can I know about humidity build up in my place, and what actions can I take if I know that I need to open a window and so on. And so we identified all that. We kept an initial pilot in student accommodation for a couple of weeks, developing data, trying to identify dew point, what's the point that you will have liquidification of the humidity in the room, and looking at the space of a couple of weeks in order to be able to identify how the situation may improve if you put actuation in place. If you turn the heater on, if you turn the humidifier on, and so on and so forth, depending on external temperature and other factors, occupancy, if people are in the room, and so on and so forth. So that was sort of the initial take that would happen in collaboration with students that used the sensors in student halls, and we developed a picture of how they could potentially improve with elementary means the build-up of moisture in the rooms. And now we're in a phase that we can improve the kind of rollout of the study. We identified, if you like, better sensors, more sensing elements. That was 2-3 years ago. There's enough space in the world of consumer electronics to improve a lot. So we've got those are the smart sensing kits manufactured in the Fab Lab in Barcelona, the Institute of Advanced Architecture in Catalonia. And we're planning to roll out the study with more locations and doing a bit more coordinated study of how behaviors of occupants may affect the buildup of moisture in rooms. Because now we've got a better sensing element. You see the sensor board here is built on an Arduino, and it includes something like half a dozen sensing elements plus a quality sensor. And we measure temperature, relative humidity, noise levels, ambient light, pressure, CO2, VOCs, and particulate matter 2.5 and 10. And it's all data that could be very usefully correlated, or even provide opportunities for further research that go outside the scope of humidity build-up. And as I said, we're planning of deployment of a number of these across the city and not just student accommodation. But that kind of sensing can happen in any environment. It's not just a residential issue. And in line with these kind of studies, we also started a study of how people work in space. That became very topical with the pandemic. That's a thing we did a couple of years before the pandemic, and we're planning of doing something in the context of a new campus we're building by Temple Beats train station, where we looked at effectively the use of open plan offices and hot desking practices, and whether you could improve this kind of desk allocation using sensors. Generally, people just tend, in most cases, to walk in an open plan office and get any desk that may be available to them, if that's kind of policy, or you may have the extreme policy where people have their own desks and work very territorially, and that's the only desk they will have, and so on. Anything else in between is something that it's not optimal, if you like, but I'll explain what we did here first, to think of a theoretical model that would optimize allocation of desks based on people's personal preferences on how they would like to be seated if they were to be allocated a desk, not at random, but taking into account, for example, whether they like a quiet place to work, or whether they can tolerate more social interaction, intense noise, whether they like the corner to be warmer or lighter, and so on. So there's a number of physical preferences as well as social preferences that could come in as inputs into a model that can take, or pre-pandemic anyway, some kind of arrivals to the office and departures to the office distribution, and try and produce a bit more clever allocation rather than the either very regimented territorial, this is our corner for this department, this is our corner for the other department, or first in, first out, but something that would dynamically allocate desks to groups that are conceptually related, either because they have similar preferences in terms of spatial location and its conditions, or they have some proximity to what others are doing. Because they're working on the same project, or they have the same role, and they need to be together. And we can measure that with some kind of proximity metric that we define very simple as sort of, the distance from where you're sitting with somebody have similar preferences to you or not. And that's all theoretical, and you can show that you can get huge reductions in real estate needs of 30% or more. And of course, for expensive real estate cities like London, New York, and so on, somebody who's running an open plan office are able to say, well, actually, we can have the same output by cutting costs by 30%. It's a huge amount of cost savings. And of course, this is a discussion now that will be even more intense after our experience of the pandemic. Remember, this all started as an idea before the pandemic. It was about 2016, 2017, we started looking at this. The reality is that was all theoretical modeling simulations, and we'll say, okay, can we support this, and can we develop an optimal system that somebody would just walk in and get a computer to give them an optimal place for their preferences. So we had, well, a couple of studies, really. This is the study we published in the university data and an allocation of an industrial sponsor that we run a parallel study. We had about 15 people taking part for a few weeks, and we instrumented in the university with one of our engineering mathematics labs, where we had essentially students coming in to work, and they all consented to come in. Instead of grabbing the first desk as they would do as business as usual, they will consult a computer somewhere in the corner in the reception, which desk to be allocated that day. We had run a preferences questionnaire before that, where people sort of told us about the preferences, whether they like more light corner here. You can see there's more windows, there's more noise on this side because it's the entrances and also a piece of corridor outside. And there's more socializing opportunities internally to here because there's some kind of meeting space on the side. And so we recorded all that, and we run an algorithm that would give people the theoretical optimal allocation where to sit for a period of 2 to 3 weeks. We used sensor set called Tinkerfords for that. We're measuring things like sound intensity, ambient light sensing, and temperature. And we're getting real-time feeds to match sort of the places of the different desks to the preferences of somebody who would come in and get a number for a desk to come and sit. And that was something fun and engaging, if you like, for the students for the period we ran it. But in reality, what we're doing, testing across a questionnaire for people to come on board to a study like this, and that this would be workable way for somebody to come in and work in the labs under this kind of circumstances. Our ambition back then was to then build something that would plug into the context a lot better. So knowing what people are working on, even knowing the calendar, to try and bring people together that they ought to be together, and we say in the relevant papers that you can use this kind of method maybe in business incubators, like the engines that I mentioned earlier, so that you can bring entrepreneurs together as a LinkedIn, if you like, layer that somebody might be onboarding the facility so that they can start a new business. Who else should they be talking to? And can a system like that get them together in a physical space as they hot desk anyway, to be together collocated so that you facilitate further innovation? We also looked at something like the Iot Test, which is a pre-instrumented furniture, and whether that would work better than our proprietary approach of sticking a spaghetti of sensors on top of the desks and so on, as you see here in the picture, with the Tinker folders and the allocation computer. So there's a lot of possibilities for further work. With the possibility also of running machine learning, we know that was analytical in fact there's an algorithm running some machine learning in place to do the matching as best as we can with analytical approaches. But there could be another step that somebody could try machine learning approaches in a data set that is similar to what we're generating here. So that's possibilities from within the built environment and looking into things like occupancy and comfort, energy consumption, for example, and so on. And I mentioned that another test bed we have is the iconic lift and suspension bridge. My colleagues in the civil have long-standing collaborations with the trust that runs the bridge because it's in our neighborhood, and they've been studying in all sorts of ways before sort of we deployed our own infrastructure there anyway. But the first thing we did, and ever since sort of this initial system, we've added a lot more sensors, both environmental and things like anemometers and so on. But the first sort of deployment we did was a wireless structural healthcare monitoring system comprising a number of accelerometers, somewhere mid-deckish and at the end of the deck, transducers, and displacement transducers so that we can measure the displacement of the deck, and wireless gateways so we can get the data back to our servers. And the objective was to see initially whether with this kind of chip instrumentation we can match the understanding we can build with the more expensive, wide and proprietary structural healthcare monitoring systems that structural engineers may be using. And also to see what we do with the data sets from a perspective of somebody who's not just interested on the structural healthcare, but is there anything interesting we could do with time series that come from vibrations of a deck? And also give an example later on how we found something interesting to do. So this is sort of the overall system architecture I mentioned earlier. So there's the wireless transmitters, the accelerometers, and the displacement transducer, and the one end of the bridge. And part of the typical output you would get, it would all go back to Kafka middleware, and then accessible by Grafana. We gave interfaces to the bridge engineers to be able to see data in real time from the bridge behavior. So this is what looked like a bit more involved. We did an experiment try and identify how much displacement is produced by different types of vehicles. So at a quiet time of day, we drove a number of different vehicles over the bridge and we sort of understood the excitation that they would cause and what kind of vibration pattern would also cause. And we started exploring the data and opportunities for doing work. So one of the things that work well with this kind of setup is that having the ability to open up, like democratize this kind of data sets, you can bring structural engineers and transport modelers and say, well, can we do anything with something that looks like this? And so you don't have to be the expert, because I'm not. I've just deployed this kind of system to grab that data. And so somebody had the idea that can we actually use the structural data that normally structural engineers would use to understand whether there's any damage in the bridge, to actually measure how many vehicles have crossed the bridge and what type of vehicles would they be, whether vans, which might be a very interesting exercise that otherwise might be very difficult computationally to do. You need to process video, for example, with all the caveats that this would bring, because you would have to have the video played, the number plates for the cars and GDPR and so on. So it's not as easy as, for example, looking at a structural data set and be able to infer traffic. And to some extent, this is doable. But there are caveats. And of course, you can understand there's a lot of noise that can enter. And how do you differentiate between two cars if they're too close together? And can you measure other things like motorbikes or bicycles or pedestrians? Under very extreme cases, potentially yes, but there are analytical approaches, at least in the beginning, that we applied that for certain signatures and certain times of day that would work well in producing a characterization of traffic. There's a relevant paper that I've mentioned there that we presented a couple of years ago, and looking at exactly the analytical methods that you could use to infer and characterize traffic from the structural data set. But the technical work is not the only outcome of this kind of thing. It's also could be very engagement with the public in different forms. In an attempt to gather more data about pedestrian behavior interaction with the bridge deck, my colleagues got involved with sponsored walk and charity, and so they had the bridge sat and schools and others walking along the bridge, at the same time collecting data about how the deck would produce sort of data in response to pedestrians walking and not car traffic. And through an internal competition through our Data Science Institute, we got one of our engineers to work with artists who produced something that looks like a suspension bridge, but it's actually a robotic car. And it essentially vocalizes the time series that produced from the bridge. And I won't play it now, but the second link here is a video explaining the venture here. And you can listen to what a time series sounds like. Vibration sounds like, it's not rock music, but yeah, it's certainly engaging. And it was a fun activity for us to get involved with. So this kind of, the ability to have access to be able to develop that insight from deploying a relatively simple system and developing the data sets that correspond to that activity gave us the activity to plug into different things, bring together different disciplines like structural engineering and transport modelers, and also even artists and the general public. And that's really, it's a good case to explain what we're trying to do with the observatory and why we call it infrastructure collaborative. Anything that is sort of captured in this way we work with the Clifton Suspension Bridge is pervasive ethos of all our activities. And as a last example, not least, is something from getting the scale even bigger, even wider rather. We started from a sensor in a room, then we're looking at the sensor on an infrastructure asset. Now we're looking at sensors on mobile things in space. Something that also happened in the context of a European project. We had an ambitious plan to work with electric mobility in general. So we had a dozen of electric bikes, half a dozen of electric shared vehicles, and an electric taxi. And the original idea was that there would be some kind of transport planner that would allow people to work through different modes of electric mobility and do multimodal, booking the car, using it for part of the day, and then booking the bicycle and using it for part of the day. But that deployment happened just before the pandemic. So the use of the bikes changed radically because we gave the bike to healthcare workers. So they were using them to visits over the past couple of years. And I've noted somewhere a piece we wrote for Ersin News, and we explained both the system architecture and you can see some of the results and the journeys that we're taking. What we're interested in is to look at things like distance traveled, how much the bikes were used, what types of journey, whether it was sort of business or people using them to go on leisure trips. Things like how much they used electric assistance and where. Bristol is quite hilly, so it was interesting for us to understand whether a capability like this would help people to take more cycling up. There's been shared bike schemes in Bristol that failed in the past, and maybe geography is part of this. And so we're very interested in seeing all that, as I said, in a different context in the beginning, but we're very pleased that actually these were getting good use throughout the pandemic by NHS workers. And so we built a proprietary sensing platform to go with a bike that has a GPS accelerometer, interfaces the canvas of the electric bike, as a UPS to power up the electronics and wireless connectivity. We also had provisions for potential in the future, using it in we didn't integrate in here, and it wasn't an intention. The paper were horrendous, but things like wearables and things like that, so we can get data from people's vital signs as well when they're using the bike and how they feel about that and so on. But that wasn't part of the objectives anyway. It's just an expandable sensing kit that could include this kind of activities. And I think we had them in operation. We still have them in operation for over 2 years now. I think there's one maybe missing in action of the 12, like stolen or at the bottom of a river somewhere. But the rest are well and still used. And we've got ample data showing trajectories and use of the battery, how much assistance, torque, how fast they were going, and so on. And as I said, they were meant to be shared resource. Well, they were shared resource, but not in the original way it was planned, but nonetheless really useful to have them as a capability in the city over the last couple of years. So this is the type of activity that we support. There are a number of other things along these lines that I have mentioned, for example, earlier in passing about monitoring the water quality. In the floating harbour, we're very interested in making predictions of water quality based on less chemical sampling and more data sort of acquisition from the vicinity. It will simplify a lot the procedures for determining whether it's safe to have an event around the floating harbour. Or if anybody jumps in, you need to go and rescue them immediately if the water is, if the data is not very good from water quality side. And other interventions have to do with understanding the impact of traffic and outside schools and working with people and small citizen communities that may be interested in evaluating how spatial layouts changes may affect them in the vicinity, and whether sensing solutions can provide part of the data for that. And as I said, a number of scales starting from the very personal to the sensor in a room, all the way up to a mobile sensor in the city. And I mentioned that, well, that's really an area many of you may be working in that, whether it's from a cloud or infrastructure perspective. On observatories, maybe for an answer to, okay, what really makes a city smart? After all, is it about the technology, the data you can build on that technology? And certainly, our view is that this kind of capability, having something very called an observatory or some kind of capability in the city that is based between a university, city council, key stakeholder organizations that really collaborate together. That's certainly part of the picture. That's kind of collaboration that needs to exist at city level to produce this kind of data and build the insights on part of that. But that's, if you like, it's a technologist like myself answer to that. The challenges that come with trying to introduce this kind of ideas in the city, things like, would people care? Is that really the priority in a city that faces big demands on housing and years of efficiency cuts, for a better word, in local government budgets and so on, and is sort of deploying sensors a priority? And would people buy into this and use the solutions that you may advocate as part of the problem, part of the solution? Would people take part even if they see the value in this and say, okay, well, actually, yeah, I do care about this problem, but can I do anything about it? And how can we meet the needs of so many different people that at the wild, remember, we're not in the four walls of a lab, we're talking about activities in the city. Can we sort of take into account the needs of so many stakeholders? And one of the challenges that, perhaps more than anybody else, we had, because of the nature of the multi-project and multi-stakeholder involvement. In our observatory activities, who owns the data? If we do all this activity in Clifton suspension bridge and it's the data, how do we then democratize that or make it available, and what are the processes? But of course, there are many caveats. In that, if not anything else, issues of privacy. Obviously, in a study that get back to the dump, you can't really go and put people's details and, with addresses and whatever and publish that as an open data set. So there's a duty of care and moderation that needs to take place in accordance with the legal framework and the interests of stakeholders that need to be coordinated here. And this is sort of part of the role, if you like, of an entity like the observatory, to understand these needs and make the data usable to the extent possible, with all the caveats that may come with privacy and other concerns that come with using urban data sets. So if smarter cities are the answer to anything, it's not merely because we deploy our technology in the cities. Why, in itself, probably that's not an answer to nothing. Because for the people administered, what is the city but the people, to use the Shakespeare quote. And you can only try and mediate a reality where people have their own understanding of what the city and their needs are, and try to get them on the same page as the 7 blind men touching an elephant metaphor, where everybody thinks is a different thing. And maybe the role of an entity like an observatory is to actually coordinate this kind of activity and bring people on the same page, understand their needs, and try to demonstrate the value through this connection. So on the one hand, with technologists deploying testbeds, because we like that stuff, we certainly like talking about sensors and the data you can get and the capabilities you can build. That's what my training was about as a computer scientist. On the other hand, it's about creating what I call the soft infrastructure, the relationships and the alignment of interests, and understanding who should be involved in the discussion, who shouldn't be left outside the table, and how would people get access to the value that you can generate with this kind of solutions. That is never easy discussion, never easy debate. And I think it's also part of an entity, as I said, whether you call it observatory or not, but somebody who will sort of work in embedding urban sensing for the central infrastructure of the cities of the future, whether this would sit with a city council or a university or a third sector or a collaboration of all of these is to be seen. The observatory is merely exploring the space and what it could be that entity in terms of organizational form and in terms of technology access and so on. So I'll leave you with a nice sunny picture of Bristol in August when we have the balloon fiesta. Thank you for listening to me. I'm very happy to answer some questions.
Great. Thank you very much, Theo. So, and don't all ask at once, please. Okay. Do we have questions online? I have a question, if I could begin. So when you started the idea of an observatory, for me, the observatory is very much about aggregating this data together. So you presented a bunch of case studies. You have the white project, but how do you pull all this together? Because ultimately you want one aggregated view of the city, right? That's what observatory is.
Yeah.
So what would be the next step, and what would be the scale up needed in order to achieve that?
Well, the capability to bring the data is there because it comes back to the same end, if you like. So it's not difficult for somebody to start making associations or correlations of what other data sets we can add, whether they're public, like weather, Met Office data sets and so on. And in our case, we do per need. People saying we have this problem to solve, and we say what kind of data we have here available that we can, if we were to join up the data sets with all the caveats that and the data agreements and everything else that may need to be in place, and we work to solve that at the time to bring the data sets together. So it's a little bit different from the ubiquitous sensing and having the data in place. Partly indication of the fact that people will not necessarily be comfortable in having a panopticon kind of thing in Hoover and everything, but having the capability to do this in a way that would be demonstrably, it will be aligned with the purpose. Like, why are we bringing this and this data set together? Because we think that by associating temperatures, external mobility data, and well-being data, we can demonstrate that we have a project that we're looking at with a local artist about an installation of trees in one of our open spaces as a greening intervention. We want to put sensors so that we can measure whether people are using the space when eventually will be with trees and green elements and so on, and what type of activity will take place there. And there will be a case of collecting different data sets of weather, was it nice weather when there's 5 people sat there and had lunch or had a business meeting or whatever, and then infer interesting facts from that. But that would come as an outcome of the alignment of many different purposes. Somebody wants to demonstrate that the greening feature can improve well-being, and somebody care about having a nice feature in an open space that made it so concrete. And we try to work on that basis, that we can, the data can exist independently, but if we spot the opportunity to bring different elements together and solve a problem, then we will do per need. So it's
it's aggregating data from a particular perspective. Okay.
So it's problem driven and taking into account, trying to align purpose of different interventions that may have produced different data sets that we think, actually, if we bring all that together, we will have the possibility to have a greater insight into a problem.
Sounds great. Excellent.
So how many streams you are sending from Bristol Suspension Bridge? Because we are using Kafka. So I just want to see that whether it is not a heavy solution or something that.
It depends on, because that would be scalable in the sense that that initial deployment was something like 10, 20 different things, like accelerometer measurements from 4 instruments, displacement, transducers every, few seconds kind of thing of motion. But we've amended that with contextual data, with we've got weather stations, we've got thermometers and so on. So it depends on how much you want to deploy. You can cover it with accelerometers and have like 30 high quality instruments, or you can take the smart citizen kits and put 200 of these and do studies of whether lower quality and more information, high resolution of noisy data would produce the same results with the scientific instruments that we're using on that study. So it would be a matter of what's the deployment at any given time. It could be hundreds or.
And have you deployed a server close to?
Yeah, there was one in here. There was one by. In that instance, there was one the gateway, and it was going back to university from there.
So it's too wireless or.
So it was some semi-local here by the end of, which is actually a visitor center on this side. So we had some local, so we've got a computing facility, and then it was going back to the university systems from there.
And then you're monitoring the vibrations or.
So that's outside the deck, meaning in the server. No, that's on solid ground. So that setup here is
Sensor is there on the suspension bridge.
Yeah. So that is not vibrating. If that's what you meant, we're not destroying our computing infrastructure in the backdrop. So it could, it could be depending on what the experiment would be. As I said, my colleagues were interested in looking at what kind of can you get credible information by a larger deployment of very cheap, very low quality sensors versus this accelerometers we had here that are more scientific sort of measurements, and that's why there were only a few of them here and there, 4 of them. And so there would be, depending on the experiment, we would support the corresponding number of inputs.
So I saw that you have a number of sensors. Do you build those sensors or you buy it?
Some are proprietary built and some are bought off the shelf. So it's a mixture of things.
Okay.
Yeah. Things like weather stations and thermometers and so on, they're all built off the shelf. Some of the sensing elements for example, the dam studies, the original ones were built in-house. The SDKs are bought off the shelf. We were collaborating with the IAC people and building some proprietary equipment for measuring things of interest outside English spaces, for example. The thing I mentioned earlier and other similar projects that will be built by us, having the components coming from them. So it's again a mixture of approaches. Some in this study in particular, part of the objective was to look at off-the-shelf low-cost components and whether you can create something that would be of equal quality of the scientific measurements that a specialist consultant could do, and whether you can complement some of that cost with an operation of a cheaper system.
And we do some data quality or imputation somewhere on the sensors, or it's in the sensors?
No, in this instance, there was nothing on the edge. It was all like coming back and doing some data quality in the back end.
But eventually you want to do it on the sensors, because if there are millions of sensors, thousands of sensors.
Yeah, that kind of problem would be absolutely really interesting, and having computation on.
And then we could throw a lot of that computing there.
Come to it. Any more questions from the room?
Yeah.
David, do you have a question? Okay. Are there questions online? I think I just had one more question, picking up on Ashik's last point. So the question is, right, that we're moving towards edge computing in many ways, in many cloud environments, as was also mentioned in the talk this morning. So I guess the question is that what we think in edge computing is it just another technical sensor sitting at the edge rather than a data center? But at the edge also sits a user, right? So the question is that how can we leverage the user better in terms of maybe, trying to, so if the sensor tells me something and the user manually enters something, what happens if they disagree? So how do you so co-creation is, about not, creating or getting users involved in the design process. But what about using users as sensors? How would that change the dynamics of what you suggest?
That's an interesting problem. I think for us to do that, if we were to like, for example, a layer of, say, social networking inputs, we would, in the past, the way we've involved users, like I suppose, could be replicated in this kind of sense is to try and develop a skill set by the organization, say for workshops or getting people to understand what is measured, what's the purpose of the measurement, so that they're serious about it. And in previous project has worked well in the sense that actually making overt how the technology works and what it is able to understand and what not, because some people might actually thinking this is fine and it's intrusive and so on and so forth. But by making that clear and by giving people the ability to have some saying in the way it is designed, like with the damp sensor, I think it motivates a lot of people to be part of the initiative, and so it raises the game a little bit in terms of whether getting engaged with the activities, or they would facilitate in other ways for making sure that they use the sensors correctly and so on. Reconciliation issues in terms of if you have human input, and I think that's something that it's good to have open research problems. How do we do that? Let's find out. The whole aspect of this is collaboration, hence it's good to pose this kind of questions. We never had a need to do it on the fly in the portfolio of activity we have, so I wouldn't have a specific answer. But as I was saying, that as part of our co-creation ethos, that the user would have to have a enhanced understanding of what is sensed and what's the purpose of sensing, and how this can be of value to the user. And then you've got a motivated individual who will spend the required resource to engage with the technology in order to help producing better inputs.
Yeah, one benefit of the edge would be that you would be sending only high quality data to the data center, because as the scale goes up, you cannot clean data, and if you are sending a lot of different readings and measurements, eventually that may require a lot of efforts. And machine learning engineer, to some extent, they will not be spending a lot of time to clean that data, and as a result.
And I can think of proof as I said, we haven't come across the need to do this, but if you think of applications like Waze and, the way that, people report accidents in, the traffic networks and Google Maps and so on.
Social GPS. Yeah.
Exactly. So that kind of thing, it can work. I think, there's examples that are tangible because people get the value back of it. If they know that actually this would help me as well, I can add a credible report or actually say, no, this doesn't happen. I'm at the vicinity and that incident has finished. So you can get people motivated like that, so long as they understand the purpose of the solution and they want, because of the value they see, they want to be part of it. I think it's perhaps part of the solution to this. I haven't seen it in context in the projects we're doing to that extent, but it's certainly a really interesting problem.
Yeah, for example, if there are kind of devices intelligent, and then there is a bid, so maybe the bridge shuts itself, say, oh, by the way, they are not safe to use. So,
yeah, absolutely.
Yes.
There were too high winds or whatever.
Yeah, yes. Currently, then data would be coming to a data center, then would be analyzing, and then sending engineers and all that. So probably it would make a lot of interesting applications.
Absolutely. So so we develop, if you like, the capability, and that's why I mentioned this is more about test beds and the way we develop them with everybody else who might have that interest. So for me, there's another dimension to it, which is the process you go about doing this in a way that is purposeful and meets the purpose of the stakeholder that runs this, but also the person who uses it, the technologist who plants the sensors there and play with the data. And somebody who just admires and takes pictures, like myself here. Well, it's not my picture, but takes pictures of the structure and uses it in the slide decks and so on. So,
Thank you, Theo.
thank you very much. Pleasure.
It's coffee break. Will be coming in half an hour. And then we'll be doing our last. So, the last session is quite long. So.